Okay, so welcome, and now we're going to look at example 6 here. Now, in the definition of the matrix vector product, the width of the matrix equals the height of the vector. Okay, and I kind of alluded to this, pointing this out in the other examples as we were doing this. That being the case, hence, this product is not defined. Notice that the number of columns here is not equal to the number of rows. This is not defined. What do I want to say? The 3-wide matrix represents a map with a 3-dimensional domain, while the 2-tall vector represents a member of a 2-dimensional space. So the vector cannot be in the domain of the map, right? Because that's what you're trying to find. Trying to find the representation with respect to the domain. And so that's why those dimensions have to match. Okay? Now, one of the things that I did do is looking at this, well, I alluded to this as well, but a good way to view this is looking at it as a dot product of the rows of the matrix with the column vector. Okay? Because what you have to do is you have to multiply each row of the vector, right, with each column of the matrix. So 1 goes with this column, 0 goes with this column, but then we run out of rows, right? So we can't finish the dot product. Now, if this was a 3, or if this 3 was a 2, we'd be fine. Okay. What else do I want to say? The other thing too that I had alluded to before is also looking at this like a row by row way, and this new operation generalizes the dot product. We can view it as a column by column operation. Okay, so let me draw this out. Let's see if I can do it this way. I think I did it similarly. Yeah, if we do this, we have H11, H21, all the way to HM1, H12, H22, all the way to HM2, and of course H1N, H2N, all the way to HMN. And of course here we've got C1, C2, all the way to C sub n, right? And notice that this is an M by N matrix, and this is an N by 1, right? So we can write this also as a linear combination of the columns, right? Which we should be familiar with. So this we could write as C1 times H11, H21, all the way to HM1, plus C2 times H12, H22, all the way to HM2, plus dot dot dot, all the way to, C sub n times H1n, H2n, all the way to HMN. And this result is the columns of the matrix weighted by the entries of the vector. And this makes sense based on our previous discussions about the objective stated at the start of this section, that we want to compute H, right? The mapping of the linear combination. We can bring it in and we can write it as a linear combination of the mapping of each individual basis vector. And that's it. All right, cool.